Hello students, we are starting our next chapter, nuclear detectors and counters. So before going to the chapter, how we are going to detect our radiations, how we are going to detect and count the radiations. So in order to know how we are going to detect, we should know the interaction of radiation with matter. How this radiation is coming out from the nucleus is interacting with the matter. So, before we are starting into the detectors, we are going into the interaction of radiation with matter. So, the radiation could be of charged particles, photons and neutrons. So, the interaction of these particles with matter has to be studied in detectors and counters. So, the interaction of any type of radiation always involves charged particle at some stage in the process. Even though there are some uncharged particles or uncharged radiations coming out from the nucleus, there involves some interaction with the charged particle at some stage in the process. So for uncharged radiation such as gamma rays and neutrons, there is a transfer of some of the energy to charged particle before there is any effect on the absorbing. So these are the process we are going through inside the detectors and count. Now first is charged particle interaction with matter. How is charged particle interacting with matter? When a charged particle interacts with matter, it loses its energy due to the action of its electric field. Since it is a charged particle, it will be having the effect of electric field on the atoms it is going through. Okay, and it encounters as it passes through matter. Most of the energy is lost to electrons. So, owing to owing to small mass of the electron, it carries away most of the incoming energy than the heavy nucleus. So, this energy will be received mostly by the electron. Since it has a small mass, this will be mostly given to the electrons than that of the heavy nucleus. Unless the energy is very high, the ions will have very little effect on the energy loss. Okay. Now, how is the interaction of gamma ray with matter? So, there are three main processes by which gamma rays or X-rays, these are the highly energetic radiations, how it is interacting with matter. This is our second category. They are of three types. First one is photoelectric effect, second is Compton scattering, and the third is pair production. So, what is photoelectric effect? This is also, you have studied it earlier. Just go through it. When a photon collides with an atom, it strikes against the orbital electrons and transfers all of its energy to the electron and removes it from the atom. This process is termed as photoelectric effect. This effect is predominant for energies below 0.1 mega electron volt for gamma rays. Second is Compton scattering. In this interaction, a photon collides with a free electron, and after collision, the photon emerges with a low energy and the electron recoils with kinetic energy depending on the scattering angle of the scattered photon. Right? Third category is pair production. It is the process of conversion of the entire photon energy into the creation of an electron-positron pair in the presence of atom is called pair production. And during a pair production, the photon energy, which is the incoming radiation, is completely creating, fully transforming into an electron-positron pair. Okay, that process is called pair production. So these are the three types of interaction of photon or gamma radiation with matter. Now, pair production requires the presence of a heavy body for the conservation of energy and momentum. The third category is interaction of neutrons with matter. Since neutrons are uncharged particles, their interaction with matter is mainly by the nuclear reaction, which depends strongly on the energy of this particle and the nuclei on which the neutron collides. So it depends on the two factors. One is the energy of the incoming neutron. Second is the nuclei on which it collides. Okay. Neutrons could be scattered, in which case the recoiling nucleus takes away most of the energy. Now, for the experimental study of the interaction of radiation with matter, we have to detect all the radiation. Both charged and uncharged radiation has to be detected. For this, we make use of detectors and counters. So, this is an introduction to the chapter of nuclear radiation, nuclear detector.